Thank you so much, Kelly. What a super conversation. And we are so grateful for John and the American Family Institute's support for Water Innovation Week. You both did an amazing job setting up for our demo day. My name is Ellie Barker. I am the program manager of the Imagine H2O Accelerator. Some of you may have joined us for our virtual demo day in March. It is great to be here with you again as we check in on all of the 2020 companies. As you can imagine, this has been a bit of a roller coaster year for our founders, but we have been deeply impressed by their resilience and progress in the face of absurd headwinds. All of them have made significant forward progress, as you will see, whether it's technical development, completing funding rounds, making key hires, deploying remotely, building revenue. This crew have proved what we already knew, that they are the real deal. All of them are well placed to build companies of real consequence and impact in the sector. This is their last hurrah with the Accelerator. In just over 1 hour, they will be alumni of Imagine H2O. So I want you to all be sending strong digital vibes their way, as you would be if you were in person. Each founder has 5 minutes to pitch, and they have members of their team on standby to answer your questions in real time. And please do connect on the platform during or after their presentations, whether you are a customer, an investor, or if you know someone in your network that would be willing and able to help. We want this to be a feeding frenzy of interest in their solutions, so please do not be shy. Once we're done, we will be giving out 2 awards. Firstly, we will be announcing the top company of Imagine H2O's 2020 Accelerator as selected by our exceptional panel of judges. If you don't know our judges, then check them out on our website. Whoever wins is getting the nod from some of the top names in the industry, and we're very excited to say who it is. Second, we are giving you the chance to select the winner of the Audience Award. So please take notes as you go and select your top company when we give you access to the Google form at the end. We'll make it very obvious, don't worry. All right, and that's all the housekeeping. Let's get going. Up first, we have Matthew Rosenthal, CEO of Sewer AI. He is dialing in from across the water from me in Oakland. He and his co-founder, Bill Gilmartin, are hard at work successfully making the sewer industry sexy again. I will let him tell you how they're doing it. Matthew, the floor is yours.
Thank you, Ellie. Hello, everyone. I'm Matt Rosenthal, CEO and co-founder at Sewer AI. At Sewer AI, we are putting artificial intelligence in the sewers. Yes, we're really doing that. And we're doing that because we have a huge problem. Every year, over 860 billion gallons of raw sewage overflows from our nation's sewer systems into our cities and waterways. It's gross, unhealthy, expensive, and it's happening everywhere across the country. And it's happening today because we have not been investing in our nation's underground infrastructure. The last major investment was the 1972 Clean Water Act, and since then, the pipes in the ground have reached the endpoint of their useful lives and are now deteriorating at an accelerated rate. We wanted to attack this problem, so we put together an all-star team to help solve it. I've been building sewer inspection software for over 10 years, and my software is used across the country in 43 cities, 22 states, and Canada. To really get an expert on the physical sewer inspection world, I joined up with my co-founder, Billy Gilmartin, who has been running a sewer inspection services firm for over 9 years, performing work for many major utilities across the country. We also put together a rockstar sales team and an engineering team. We put this team together to really help the person that is responsible for managing the sewer systems. This is the director of wastewater or superintendent of collections. Nationwide, these directors have a budget of about $50 billion, and they spend it to maintain our aging systems. The 2 main levers these directors push on to fix infrastructure are inspections and repair work. At Sewer AI, we are building tools to help with inspection and repair. These are the first tools we are building in our mission to fix the world's infrastructure. We are building AI and cloud platforms to help lower the total cost of maintaining utility. We are starting with inspection, so let's dive a bit deeper into how it works today. Today, to inspect a sewer pipe, a 2-man crew drives a box truck out to a manhole. They lift up the manhole and lower a tethered camera down into the sewer pipe. Then they get back into the truck and drive the camera down the sewer pipes looking for roots, cracks, grease, anything that affects the flow through the sewers or its structure. This process has quite a few challenges, but the biggest ones are speed, cost, and consistency. The speed is the biggest challenge, and the reason is it is so slow is because every time the operator sees roots or grease, he has to stop the crawler and swivel over to a keyboard and mouse and enter that information into a database. We have found that 2/3 of the time the camera is down in the pipe, it is not moving forward, it is idle. 2/3 of the time. This is a huge time sink and it's very expensive. The typical cost per foot of inspection work is upwards of $2 a foot. I know this varies by location and deployment type, but no matter where you are, this is expensive and slow. So we set out to speed up inspections. To do this, we built AutoCode. AutoCode is our AI system that turns inspections from a messy art form into a consistent and fast science. The AI automatically labels defects so the operators no longer have to stop at every defect. We're using AI in the cloud to code videos at 8 to 10x the normal speed. This is the same workflow as the medical industry where they're using AI to speed up review of x-rays. This is giving the CCTV operators in the field a massive speed improvement. The operators in the field are no longer stopping at every defect and are able to recapture that 2/3 idle time and convert it to productive time. Teams are now seeing 3,000 feet of production per day instead of 1,000, and the cost to collect video drops from $2 a foot all the way down to 92 cents a foot. The data they are collecting is also much more consistent. It's really game-changing. How did we build AutoCode? We built a huge data library with millions of feet of data and hundreds of thousands of images, all being reviewed by trained technicians. But the real value of what we built is in the testing. We are really a testing company, a company that is constantly testing our AI. We have over 73,000 individual tests. This is the value of what we have built so that customers can trust the output of what we provide. Here's a little demo video showing off the technology. The AI is predicting defects and it's drawing a bounding box around each one. It is also showing its confidence level. I like to compare us to Tesla and their journey to build a fully automated self-driving car. Today, Tesla is not finished, but every year they're adding 1 billion miles of new training data. They aren't at full self-driving capability yet, but they are working towards it. While we don't add 1 billion miles of sewer inspection data every year, we are adding hundreds of thousands of images every month and thousands of new test cases every month. And we know we aren't done. And because we aren't done, we still manually review every defect predicted by the AI, and we manually watch every second of every video. But every new customer and every new foot of pipe we inspect brings us closer to the point where the system will be fully automated. And just like Tesla, we are a big startup on that journey to full automation. We recently raised $2 million in seed capital, and we just kicked our sales into full gear. We have found that both cities and contractors are loving the technology. We have projects already with 7 cities, 5 contractors, and 1 consultancy across the US and Canada, with 16 more projects queued up. But it's not just utilities and contractors that are loving this technology, it's also the operators out in the field that are truly appreciating the value we're providing. Raymond in Northern California said, "I used to do 2,000 feet a day, now I can do 3,000. Everyone's got to get sewer AI." These guys out in the field are getting much more work done in a much safer manner. I know a lot of folks out there are dealing with inspection challenges on a regular basis. If you're interested in reducing costs, accelerating productivity, and improving your accuracy on your sewer assets, please reach out to us at Sewer AI. If you are an investor and would like to meet with us to discuss investment opportunity, please reach out to us as well. We want to hear from you. Thank you.
Thank you, Matthew. Next up, we have Derek Du, CEO of IoTank, who is joining us just south of me in San Francisco. Derek has some serious IoT chops and has decided to use his skill set to tackle another sexy industry, one full of fats, oils, and grease. Derek, over to you.
Thanks, Ellie, for such a warm introduction. When you think of restaurants, you may think of fancy tables and amazing views. There are more than 1 million restaurant locations in the United States alone. What you don't see is all the fats, oils, and grease that are going down the drain in the kitchen. Restaurants manage this grease with a grease interceptor, and each interceptor is required by regulation to be pumped out at 25% full or every 1 to 3 months. So how does a grease interceptor actually work? A grease interceptor is a tank that separates the grease from the water by allowing the grease to float to the surface and the excess liquid waste then to flow to the centralized sewage system. The tank needs maintenance when the grease levels get too high. If this happens, grease can begin to exit the tank and build up in the centralized sewage system, causing sanitary sewage overflows, otherwise known as SSOs. Fats, oils, and grease, otherwise known as fog, directly cause 40% of all SSOs in the United States. For municipalities, these SSOs cost $160 million to remediate and result in 10 billion gallons of untreated waste entering back into our environment annually. The EPA estimates it would cost $88 billion to upgrade every municipal collection system to reduce frequency of SSOs to 1 every 5 years. The pollution generated by these SSOs are regulated by the National Pollutant Discharge Elimination Permits, created with the Clean Water Act of 1972. These permits define limits on how much untreated waste can be released back into our waterways, incentivizing municipalities to adopt new methods to decrease SSOs. My name is Derek Dew, and I'm the founder and CEO of IoTank. We are building the first tank inspection alternative consisting of 3 main components: a sensor, a communication module, and a software platform. IoTank has patented the first cost-effective sensor that measures the solids, grease, and effluent levels in a grease interceptor to notify users when they actually need maintenance. The IoTank sensor also measures wastewater production to provide predictive maintenance of external components. By gathering data across all of the different tanks, IoTank is also able to provide data-driven recommendations to municipalities, including hotspot mapping to prioritize sewage cleanings. In short, IoTank will automate maintenance of all decentralized wastewater treatment systems to ensure all tanks are compliant to local regulatory standards, providing restaurants a 306% ROI in the very first year. IoTank will have multiple revenue streams. Our primary revenue stream is with restaurants, which will consist of an affordable hardware cost and a recurring monthly subscription fee. The secondary stream is with municipalities, where we'll be providing our services for free and charging a recurring annual subscription fee for any sort of value-added services that we'll provide. And our last revenue stream will be with on-site maintainers, where we'll be charging a commission on services scheduled and booked with the IoTank platform. We expect the market size in the US to be about $96 million for restaurant, and $1 billion for municipalities, and $100 million for on-site maintainers. With COVID, restaurants' sales rhythms have dramatically changed, and thus their pumping cycles. There's been a clear demand from major restaurant chains for solutions decreasing their operating costs. That's why our first target is restaurants. We're currently performing only local installations, but Tacoma, Washington has also agreed to pilot a number of devices. Our team has a proven record of delivering products. We have developed and delivered 20 plus products that have gone to market and have released 50,000 devices into the world. We have augmented our team with advisors that are decentralized wastewater experts and experts in industry. Here's a picture of our first installation. This unit has been installed and operational for the last 3 months just to prove the resiliency of the sensor itself. To the right is a picture of the communications module and the sensor. We currently have 7 paying restaurant customers and are looking to continue to expand. We're only limited by the amount of hardware that we currently have available. Since our last presentation, we have joined UC Hastings Startup Legal Garage to build our legal agreements with our customers, and Unleash to increase our visibility among the SDG Sustainable Development Goals. We aren't currently looking for funding because we're currently bootstrapped and waiting to receive grants, but what we do need is help raising awareness of this issue. We're looking for help in introductions to advisors that understand how to navigate the sales cycle, and for introductions to municipalities that could be our future customers. We're going to enable decentralized wastewater to be managed centrally. We were able to get our first 7 paying customers by talking with only 15 potential customers. We have the right team to execute, a clear market demand, and regulations that are trending for our product. Please contact us if you want to learn more. Thank you very much.
Thanks, Derek. We are now making our way to Chicago, where Jamal Carter, CRO of Varuna, is tuning in. Jamal and his co-founder Shay have also made remarkable progress, notably deploying their IoT solution remotely and being selected to Imagine H2O's 2020 Urban Water Challenge. We will find any excuse to continue working with this team. Jamal, take it away.
Thanks for the introduction, Ellie. In 1908, US cities began to use chlorine to disinfect its drinking water. And to ensure chlorine levels were safe, the utility would take grab samples from the distribution system. Fast forward today, around 98% of water systems in America use chlorine in their disinfection process. And guess what? They still sample residuals the same way they did over 100 years ago. It's no wonder that recently over 63 million Americans were exposed to unsafe drinking water. And for over a century, water utilities have performed routine sampling to answer a timeless question: what's going on? And specifically, what's going on in my distribution system right now? I want you to meet Darren. He's one of our clients. Darren's seen here flushing the system to increase chlorine residual levels in the northeast part of the city, where the demand for water is lower than expected. But prior to actually taking this action, Darren had to drive 13.2 miles to this location, turn on a spigot, take a grab sample using a kit, record it on a piece of scratch paper, determine the corrective action to take, drive back to the treatment plant, log it onto a notepad, and maybe it made it to Excel. Listen, you get the idea. It's a really, really cumbersome process. And Darren, along with countless of other techs across the nation, do this every single day. Something has to change. We've arrived at a point in time where utility managers can either let these macro trends continue to create unbearable pressures on their operations, or they can change the way they do things. And Varuna knows that water system managers will opt for the latter, and that means using data. Varuna is reimagining how to use data to run a sustainable and resilient water utility. And we enable water operators to see beyond the fence of the water treatment plant into their distribution system. We do this by deploying nodes that are outfitted with water quality sensors, and the data is then transmitted to the cloud, where we run analysis and provide situational awareness to the operator so they can make the best decision about where to spend their time and money. So now the operator has visibility across the distribution system to understand what's happening in real time with things like chlorine residuals, pressure, and turbidity. And in Darren's case, with enough data, we can begin to predict contaminant shocks and recommend optimal remediation workflows. Varuna is focusing on small to medium-sized utilities in the 2 states you see in front of you, as they represent our beachhead market. And it's paying off. Since the pandemic brought the US economy to a screeching halt in March of 2020, we've gained 5 new customers. We've been selected to the Urban Water Challenge. We were awarded a grant from Google, and we've signed an MOU with the largest water company in Mexico, as well as a global engineering firm. And to top it off, we've secured a term sheet from Corazon Capital as we move to raise a seed round. We're repeat founders, having sold our first startup, Power to Switch, about 5 years after it was founded. And we're supported by an amazing group of advisors like Johan Schwinn, who's a savant when it comes to practical IoT design, especially in the water space. Aside from our team, Varuna's unfair advantage is in our systems thinking approach to building software in our price segment match that allows us to provide more value than our competitors and do so at a reasonable price. We're raising a $1 million seed round led by Corazon Capital, and we'll use these funds to get us to our next milestone of working with 20 water utilities to give them visibility, awareness, and insight of what's happening throughout their distribution system. Water utilities understand there's too much at stake for them not to know what's going on in real time, and Varuna is helping get them to that future state. If you're interested in joining us on this journey, we'd love to chat with you. Thank you.
Thanks, Jamal. And it's up and over the border to Quebec City we go. Dragan Tutik, CEO of Oneka, is our next presenter. Dragan's technology continues to amaze everyone he comes into contact with. It's been a huge pleasure to work with him this year at such a pivotal point in his company's development. I am excited for him to share all of his updates with you. Dragon, the floor is yours.
Hey, thank you so much, Ellie. So yeah, I'm Dragan from Onika Technologies, and we developed a solution to make the oceans the most sustainable and affordable source of drinking water. Water scarcity will be one of the 21st century greatest challenges, and ironically, the current solution we have in our hand actually compromises even further access to drinking water. Desalination converts fuel to drinking water at a very high cost, generating a lot of CO2 emissions. To give you an order of magnitude, today there's about 1% of the world's population that uses desalination, and that accounts for 0.5% of all world's CO2 emissions. And that's a $20 billion industry just for that small fraction. At the current growth rate, the industry will tenfold in the next 30 years, and by then generate as much CO2 emissions as the entire aviation industry twice in 2019. But luckily for us, ocean also has a tremendous gift, which is wave energy. So by combining the seawater and the wave energy, we can make it an unlimited and sustainable source of drinking water. So this gives an overview of the conventional desalination that turns fuel to drinking water with many energy conversion steps. And the last one is to mechanically pressurize the seawater through reverse osmosis membranes. So what we did is that we eliminated all those components and directly pressurized that seawater using wave power mechanically. So there's no electricity in the entire process, making it very simple and cost effective. A commercial form looks like this, where we take that desal plant, we put it right in the ocean where we have the seawater and the energy to transform it. It provides drinking water to coastal users with no greenhouse gas emissions, no land use. It has even a responsible brine, and it's decentralized, providing water right where it's needed. And it's cost effective, as we can easily see in places like the Caribbean, where water cost is very high, going as high as $4 to $8 per cubic meter. And using our technologies, users will be able to get water as low as $1 per cubic meter. And in the upcoming year, the cost of the technology at the current state is about $2.5 per cubic meter. And it's not only in theory. So we've been working on this technology for the past 5 years, and we were able to demonstrate the entire functioning of the technology. We were able to demonstrate its potential by making 10 cubic meters per day per unit, and it's scalable, similar to solar panels where you put many of them to make an array. And we recently outsourced the production of all the components, and now we take care of the assembly and quality control of those to be able to scale fast. And to scale fast, the next step is to gain visibility on the operation and maintenance costs of our products. And on the commercial side, we have 2 agreements with early adopters, one in Florida for the Caribbean market and one in Chile for the Chilean market, which requires a lot of desalinated water. And this paves the way for a sustainable future for water and desalination. We start with our early adopters, move to regions with low volumes but high costs per cubic meter. We use this to grow the company, our product, reduce our costs, and be able to address water needs for millions around the globe, needing large volumes of water at the lowest cost possible. With the simplicity of the technology, we'll be able to provide the cheapest possible desalination, and that's without any greenhouse gas emissions or negative impacts on the environment. So for the next phases, we've already secured $2 million in our current open round in non-dilutive and equity financing. And we have also an excellent multidisciplinary team surrounded by key experts in our industry to get this done. And I really hope we'll have the chance to work together on this world-changing journey. Thank you so much.
Thank you, Dragan. Coming back to the west coast of the US, we have Erin Rothman, CEO of Storm Sensor, up next. She is tuning in from Seattle, Washington. Erin is an absolute master of the stormwater industry and has built her business around a serious pain point she experienced firsthand. She has also achieved amazing things this year. Erin, over to you.
Thank you, Ellie. Modern society embraced the first 3 industrial revolutions as immensely beneficial to human systems, bringing advancement at levels we never thought possible. Our world fundamentally changed and in ways we thought were for the better. As it turns out, we were enthusiastically incorrect. Along with societal changes and perceived improvements in quality of life, our actions introduce greenhouse gases into the atmosphere at rates never seen before. Average air temperatures increase, ice caps melt, and sea levels rise, ocean currents shift with the introduction of cooler water at the poles, and droughts and storms both become more extreme. This is climate change and imposes significant environmental, economic, and social risk. We are now challenged to find new ways to live, ways that are more resilient and sustainable, and that find equilibrium within our world. Now, if the world continues burning fossil fuels, the current temperature rise scenarios are expected to result in catastrophic human, biologic, ecologic, and economic loss on a global scale. With a temperature increase of only 1.5 degrees Celsius, the world could see more than $54 trillion in damages from climate change-induced market and non-market impacts, sea level rise, and associated large-scale discontinuities. It's an incredible challenge facing us today, but every challenge is an opportunity. Storm Sensor offers a solution to address flooding and sea level rise through data and through the targeted actions that cities can take as a result of the information that we provide. Our network sensors capture accurate temperature, flow, and weather data at every monitoring point, every 5 minutes, every day. Our software delivers simple, practical insights that give communities the information they need to manage the risks they face from flooding, tidal surges, and overflows. And cities use this data to streamline their operations, receive real-time system diagnostics, and guide future investments in capital improvements based on trends. Terrapin AI is our cloud-based spatial visualization software that maps current and upcoming flood and overflow risk. We provide real-time system notifications for proactive and emergency response planning, and we are working with our customers to develop new coastal and surface water features that include tidal deletions, backflow notifications, and statistical storm events analyses. Now, while the possible uses are endless, we focus primarily on 3 key use cases with our customers. The first is flood control, including urban flooding, sea level rise, storm surge, and surface water flooding from rivers and lakes. The second is critical infrastructure. The bulk of our sewer and stormwater infrastructure far exceeds its useful age, as well as the capacity that it was built to handle. And the third is stormwater model validation. Because so much of our infrastructure is failing, many cities are reevaluating their hydrologic and hydraulic models. We went to market last year and we've deployed in cities across the country, including Detroit, Jersey City, Boston, and Memphis. We partner on projects with engineering companies who are deeply experienced in civil engineering and hydraulic modeling. But we do have some work to do. Overall, the annual estimated water-related climate impacts in the United States will total approximately $132 billion by 2090. While that is a huge market, we will continue to focus our efforts on targeting the 769 cities in the United States with populations greater than 50,000 people. So let's take that beachhead market and break this down into more reasonable numbers. Looking at anticipated return on a city's investment if they deployed Storm Sensor and if they took action based on the insights that we provide, the benefit for use cases from O&M to flooding range from 4 to 12 times the amount they spent, with payback within a year for each use case. Our overall approach is to land initial deployments of 20 to 30 monitoring points in high priority hotspots. And as our data proves its value, we work with our customers to expand their networks throughout the city. Now, looking back to our last pitch in March of 2020, things weren't looking so great, but we did end up closing our $2 million seed round. We have since received $530,000 in deployment grants from RISE and the 2040 Foundation. We have identified a coefficient for each storm system that determines actual flow conditions and therefore acts as a direct indicator of flood risk. We've released our premium software platform, Terrapin AI, in beta, and we are looking for beta testers. We installed in Boston, Norfolk, Deerfield, and we have 4 more cities to go by year's end. And we have $611,000 in bookings through September 2020, which is more than 2 times our post-COVID projections. If 2020 has taught us anything, we have learned that our network is the most important part of our work. Well, that and the work we do to support our communities. To that end, we want to hear your story. The more we can share, the more likely our governments will focus on addressing climate change impacts in our towns. And if you think we should talk to you or your city, please reach out. I would love to see how we can help. George E.P. Box once said that all models are wrong, but some are useful. And right now, most of our efforts toward combating climate change are based only on models. Storm Sensor wants to fix that. By capturing real-time empirical data within highly variable systems, we provide the data and the insights to match models to reality. And that is what cities need to create the thriving, resilient communities of tomorrow. Thank you.
Thank you, Erin. We are coming back to the Bay Area where our other Erin is based. Aaron Tartakovsky, CEO of Epic Clean Tech, will tell you how his company is transforming the world of decentralized wastewater. Like Varuna, Epic Clean Tech was also selected to be part of our 2020 Urban Water Challenge. So make sure you follow their progress as they continue to get deployments in the ground. Aaron, over to you.
Thank you, Ellie, for that introduction. My name is Aaron Tartakovsky. I'm the co-founder and CEO of Epic Clean Tech based here in San Francisco. So we are decentralizing wastewater treatment and reuse into individual buildings or groups of buildings starting in cities. So what are the big problems that we're dealing with? Well, right now we continue to be reliant on centralized infrastructure. We're dealing with water and sewer rates that are rising on top of continuously unpredictable climate, and the fact that we know that 70% of the world's population will be living in cities by 2050. So we see an opportunity not just to continue rebuilding the same way we've been doing things, but to fundamentally shift the model towards a more distributed approach. So why cities? Because of this statistic. We know that more and more people are going to be moving into cities, and we have an opportunity to redesign how our cities handle both water and wastewater infrastructure. So at Epic, we've developed an approach. We actually convert a building's wastewater both into treated water, which we can then reuse on site, helping to reduce a building's water demands by up to 95%, as well as a high quality carbon-rich soil product, which we can then use in and around cities. And very importantly, we handle everything for these projects, meaning we handle everything from the initial permitting and design all the way through the ongoing operations and maintenance contracts of these systems, essentially hand-holding our customers, which are building owners and developers, to make sure that this entire process is as seamless as possible. So what does it actually look like? We are going into the basements of these large buildings or these campuses. We're first pulling out the solids. So these solids we strip out of the water, we compress, we take offsite and turn into high quality soil products, which we can then partner with cities or with parks or with nurseries to turn it into a high quality carbon rich product and actually not have to use fossil fuel based fertilizers. With the solids now removed, the water, which is more akin to a dark gray water, can then be treated and recycled on site. And in terms of the technology that we're actually using, here on the left, you can see our solids recovery technology. This is a rotating belt filter, which has been sized specifically for a building, which is to say it's not large flows like you would see at a wastewater treatment plant where you're talking hundreds of thousands or millions of gallons a day. We're talking anywhere from 500 gallons to maybe 100,000 gallons per day, which means we can design the technology differently for those applications. On the right, you're seeing the membrane bioreactor that we are working with. So we've actually partnered in an OEM relationship with an existing player to design a system that's designed to be able to integrate into a building for those lower flows and to be able to fit into, for example, a 9-foot basement. This is actually the design of the system that we'll be putting into one of our installs in the coming month. This is what we do with our solids. So on the left is the raw solids. These are from Stanford where we did our initial testing. We convert it into a high quality soil product. So what you're seeing is not a stock image. That's actually our scientist Elon's hands holding our finished product. And this is actually our first hub. We call these Epic hubs. Each hub can service multiple buildings or spokes. Here is our first facility where we are creating this product and able to use it locally. So the business model is quite straightforward. We're selling these systems for about a 45% margin. We then have an ongoing O&M contract for 10 to 20 years. Again, about 45 to 50% margins there. And then we're finally selling the soil product, which is sort of a tertiary source of revenue for us. As time develops and the market matures, we plan on doing more of a leasing style model similar to the solar industry, using either third-party financiers or dedicated project development funds. San Francisco is our beachhead market. We actually worked on the regulatory side to help pass a law that requires that all large buildings in San Francisco have to have on-site water recycling programs. We also spent about 2 years on the state level on something called Senate Bill 966, which says that any city in California that wants to have a water recycling program like San Francisco's can do so, and the state regulatory authorities will help. And we envision other cities will be following suit in the coming years. This is actually an example of a project that we would be working on. And you'll see that by installing our system and reusing water on site, this building will save almost 40% annually, which translates to close to $700,000 or compounded over 10 years, $6.7 million. Our team is interesting. We are multifaceted. We cover politics, we cover engineering, we cover science. And we think that those three things are key ingredients to being able to navigate not only a new technology, but being able to work within a very regulatory heavy industry like water and wastewater and in the real estate sector. And we also have investors and advisors who span everything from real estate to water to energy, because we want to be able to think differently and work with our regulators versus against them. We've had a very busy year. We completed 18 months of testing at Stanford. We deployed into our first building in downtown San Francisco. We actually recently closed a $2.6 million seed round, and we have a lot of projects in the works now. But one thing I'm most excited about to actually announce on this call is on the left here, it will be our first commercial install, which we are commissioning in the next month. So I invite you all to come see it, should you be in San Francisco. Finally, I'll say that Epic Cleantech is very excited to be part of the Urban Water Challenge for 2020. We're excited to use this funding to be able to accelerate our developments and to make on-site reuse not just a one-off thing in a city like San Francisco, but to actually help to streamline regulation and streamline the education with our key stakeholders like building owners, like developers, like architects, who frankly are not familiar with on-site reuse. And so we as Epic Cleantech aim to be the leaders in the field to make this not only a one-off thing that certain projects will do, but to make it a mainstream approach that all new developments will want to be reusing their water on site and will understand the regulations and the technologies that enable them to do so. So what are we looking for now as a company? Well, we're looking for customers. We want to partner with more folks in the real estate industry, and we want to bring this solution to more cities. We want to work with other utilities. We want to work with other technology partners to make this not only something that we can do in San Francisco, but in other cities across the country and eventually around the world. So thank you very much. Appreciate your time. Anyone can feel free to reach me by my email. I look forward to continuing the conversation and working with you all. Thank you very much.
Thank you, Aaron. That brings us right into the break. We're going to play a video showcasing our new product, the H2O Hub. We are really excited to share it with you, so please stick around for that. But you should still have time to grab some coffee, stretch your legs, get some real life H2O in your life. But come back, we will know if you don't, and there will be some serious consequences. So we will see you in 5 minutes.